Equilibrium concentrations using the quadratic formula, I Mr. B. Given this equation, H2 plus I2 is in equilibrium with 2HI. Calculate all three equilibrium concentrations when the Kc value is 20.0 and the initial concentration of H2 is 1.00 molar and the initial concentration of I2 is 2.00 molar. Begin by drawing an icebox. Insert the initial concentration, use the following, where the initial concentration of H2 is 1.00 molar, the initial concentration of I2 is 2.00 molar, and the initial concentration of HI is 0.0 molar. The change is represented by negative X and negative X for the reactants. Since the reactants are disappearing, we use a negative sign. So the concentration of H2 will decrease by negative X, and the concentration of I2 will decrease by negative X as well. The concentration of HI is increasing, so we write plus 2X. The plus 2 indicates that the HI is being formed twice as fast as the H2 and I2 is being used up. To write the equilibrium conditions, simply combine the initial concentrations and the change. So for H2 we get 1.00 minus X, for I2 we get 2.00 minus X, and for HI of course we get 2X. Now we write the equilibrium expression where Kc or Keq is equal to the concentration of HI squared divided by the concentration of H2 times the concentration of I2. Inserting the value of Kc yields the following, where 20 is equal to the concentration of HI squared divided by the concentration of H2 times the concentration of I2. Inserting the data from the icebox generate the following relationship. 2x squared divided by 1.00 minus x times 2.00 minus x, which simplifies to 4x squared divided by 1.00 minus x times 2.00 minus x. Now we can solve the quadratic equation. So we write 20 is equal to 4x squared divided by 2 plus x squared minus 2x minus x. And solving further, we get the following, where 20 times x squared minus 3x plus 2 is equal to 4x squared. And 20 times x squared minus 60x plus 40 is equal to 4x squared. Setting the equation equal to 0 generates a quadratic equation. So subtract 4x squared from both sides. This generates 16x squared minus 60x plus 40 is equal to 0. Now use the quadratic formula, where according to the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. In our equation, a is represented by 16, b is represented by negative 60, and c is represented by 40. Placing those values into the quadratic formula yields the following. Negative 60 plus or minus the square root of negative 60 squared minus 4 times 16 times 40 divided by 2 times 16. And 60 plus or minus the square root of 3,600 minus 2,560 divided by 32. Taking the positive answer yields the following relationship, where 60 plus the square root of 1,040 divided by 32 This is equal to 60 plus 32.24 divided by 32. So 60 plus 32.24 divided by 32 is equal to 2.88 molar. The 2.88 molar is greater than the initial concentrations, so we cannot use this answer. Now let's solve using the negative answer. 60 minus the square root of 1040 divided by 32. This simplifies to 60 minus 32.24 divided by 32. And the answer is 0.8675 molar. Since 0.8675 molar is smaller than both initial concentrations, it will be the correct answer. Now for the actual equilibrium concentrations. The concentration of H2 is equal to 1.00 molar minus 0.8675 molar. This is equal to 0.1325 molar. The concentration of I2 at equilibrium will be 2.00 molar minus 0.8675 molar. This is equal to 1.133 molar. And the concentration of HI is equal to 2 times 0.8675, which is equal to 1.735 molar. This concludes my lesson on equilibrium concentrations using the quadratic formula. I'm Mr. B.